Alright, thanks Joshua to talk about the background of our innovation. And now I will talk about the technical detail of our robots. So for robots, there are three parts of it: mechanics, electronics, and embedded control. And so in the mechanics, we use computer-aided design, the software, to help illustrate how it works. So you can see now here we use a parallelogram linkage design. So there are four bars to form the parallelogram, and the skewed push rod push at the bottom right joint to transform the parallelogram from the sitting position to a nearly linear position for sleeping. So with this parallelogram, our uh, robot can achieve an ideal position for both sitting and sleeping, right? And also, we will have a cushion that go with the device, and there are four hollow cylinders that we can insert the four bars into the cushion and then move the elders up like a forklift. So with this design, our robot is capable to move the body from one position to another. And also, this vertical push rod can adjust the height for different height of wheelchair and beds. So it is a versatile device that can fit into all kind of bed and wheelchair. It is easily moved around with wheelbase, and we hope to have an adjustable base size for the storage. Then we go to the electronics part. So here is our main force system, the electrical push rod. With this push rod, it can provide more than 150 kilograms force to the elders, which is very enough for the elder. And so here is a motor and this is a transmission. With the worm gear and worm wheel inside, it can have the huge force. And also it has a feature of self-lock. What is self-lock? So when we cut off the power with emergent, and then the push rod will remain the original position. And then we have the H-bridge to control the electrical push rod. So it can provide 24-watt power supply, and it has easy DC control with PWM signal. PWM signal is the easiest control algorithm for our programmer. And then lastly, we will need MCU, the control unit. So we will use STM32 family instead of the famous Arduino, because there are a lot of open library for STM32, and it is a mature platform. The price, this one for example, is the same as an Arduino Nano, which is around 30 bucks. But there are a lot of pins on it, so we can attach more sensors to it later. And then the last one is embedded control. So in the embedded control, you have three tasks. One is the feedback system to control the two push rods with accuracy. And the second one is the safety system. We need to guarantee the safety issue of our elder. And the last one is the user interface for easy control. For the feedback, we have the encoder. So when we turn the parallelogram transform, and then the encoder will feedback the angle of the current position. So our controller can calculate it and get an accurate negative feedback control. And then it's the safety system. So we will use the MU for XX, and the MU and the encoder from previous slide for YX, and the distance sensor for ZX. So how it works, in XX, the MU will detect acceleration in the 6 degree of freedom. So when it detects a big acceleration in any x, and it will pause the process of moving for safety concern. And the ultrasonic distance sensor, it can sense the distance between the ground and the device. So if it detects that the device is moving and it is not on a stable ground, it will not start the moving process. And then the last one is the user interface. So we hope that caregiver and the family, or even the elders themselves, can control the device by themselves with easy control. We have an Android app so they can install in their phones. And then we will also use the T05 Bluetooth module to let their phones to connect to the device through the Bluetooth. So in this way, they can control the device easily. And they don't need to use the hydraulic lift like Joshua presented to move the device. And then I will move to Leo's part. Thank you.